Hello friends, today we are going to discuss about the block diagram reduction procedure. In my previous video, I have taught the block diagram representation, many representations. You can check out by the link given below in the description. And before watching this video, it will be better if you watch that video first, because there I describe the basic knowledge about the block diagram and representation, because after that you will reduce the block diagrams and make it simple to understand. Means you will find out a overall transfer function of a huge system, and that will be the block diagram reduction. So now let's first understand some elements of any block diagram. So first one is block. Here I have drawn that with G transfer function, and input is X, output is Y. As we have discussed before, it is very simple to understand. Second one is adder or summing point. Here I have taken a symbol of an adder represented with a cross, and X signal is getting added with Y signal here and giving the output Z is equal to X plus Y. Third one is takeoff point. This is very important. Takeoff point. Takeoff point we represent with this sign or with a dot. Now what is takeoff point? If any signal is flowing through a path, we can take the same value in another path through takeoff point. Means we are taking the same value for another purpose or for another, like another feedback or something like that. Hence here Z is the takeoff and it is the takeoff point. Now there are some procedures to reduce the block diagram. Means what we will actually do, the basic idea. The basic idea about block diagram representation. Let's take an example. Here is input and there are many plants or systems like this. This takeoff point, many systems like this getting added. Here we are taking a feedback. Here we are taking a negative feedback. Here we are taking a parallel path. Here the final output. Means here output by input, when all initial conditions are 0, we take it as transfer function. Hence the calculation of transfer function of a system will be easier if we reduce the block diagram and make it into a simple block and take the same input here and same output here. Same. Remember this, very important. Let that will be X dash. The overall transfer function of the system will be X dash, and the transfer function of the system, this calculation will become easier. The transfer function identification of the system will be easier. Now there are some procedures to reduce the huge block diagram of any system given. One by one I am giving the techniques, and after that I will explain a example in my next video. So understand these points very carefully. So here first one is moving a takeoff point after any block. So let's take a block and the transfer function is GS. Let's take the output as CS and input as RS. And here is a takeoff point which is taking the value of RS actually in this path. So if we transfer these takeoff points for the sake of simplicity of block diagram, means if we go for the reduction, then if this is necessary, then what we will do? We will take the input as well, the block GS as well, the output, and from here we will take the output. But see, if from here we take the output or takeoff before, then RS should come from here. But here, if we take the takeoff from here, RS along with GS, means the multiplied version of this will come from this path, but we will get the same as before. So for that reason we have to divide GS, means 1 by GS. We have to divide it, then we have to take the desired path value. I think you have understand this clearly. Now similarly, second one is moving a takeoff point before the block. Same as before, you can understand it very easily right now. So at first here the takeoff point is, but after that it will come in forward. That means we have to multiply, right? We have to multiply. See, here the multiplied version will go, but if we take the takeoff point before, it will not get multiplied, only RS is coming. Hence to get RSGS in this path, we have to multiply GS before GS and then take the value. Only then the same value, after the transferring of takeoff point, the same value will be coming from this path. Now takeoff point is understood. Now moving point. Moving the summing point. Similarly, we are taking the input RS and there is a block GS. Now there is a summing point before the block. There is a summing point before the block and the output is going from here. Obviously some signal, let's say HS, is getting summed up here with RS. So if we now transferring after the block and getting the same output CS, in that case what we have to do? Previously HS is going in this path and it is getting multiplied with GS and then it is giving the output CS. But if we take HS here and it is now being added with GS, not being multiplied, means here CS would be RS plus HS into GS is equal to RS GS plus GS HS. Clear? Now in this case, if we take RS here, this RS here, we will get RS GS plus HS after adding this, and this will be CS, means we are not getting GSHs. We are getting only Hs. To get GSHs, we have to multiply GS with Hs first here, and then we have to take the addition, right? Then it will become GSHs here. So to transfer the summing point after any block, we have to multiply the value of that block or the transfer function of that block with the value which is coming to the summing point. Now the fourth one is moving a summing point before a block. Now the summing point is after the block, we have to move it before the block. How can we do that? Now let me draw it. Similarly as before, now we have to divide GS. We have to divide GS from Hs. You can understand it very easily. Plus plus, we have to divide with GS means multiply with 1 by GS. Then it is going to GS and we are getting the output. You will understand it very easily if you have understand the previous one, which is moving a summing point after the block. Now the fifth one, this is very important. Here the takeoff point and summing point both are present. The first one is moving a takeoff point after summing point. See it very carefully. Moving a takeoff point. Let's take this is the takeoff point, and the summing point is like this. Hs is coming here, and we have to transfer the takeoff point after the summing point. Then what it will be? Rs will, as before, here the summing point, then the output CS, and takeoff point will be after that. So in the first case, HS is going in there. So in the first case, RS was coming in that path, but when we will take this takeoff point after the summing point, HS will also be added in that path with RS. Means to get the same RS output from this path, we have to subtract the Hs value from this path value. Means we have to add another adder where we'll make the subtraction operation here, and we'll subtract this path value from Hs, then we'll get the Rs value as previous. Means to transfer a takeoff point after the summing point, we have to add another summer or adder which will subtract the value of Hs from this path, and this will be the final takeoff value as before. I think you have understood it very clearly. Now the third part, means the sixth and the final part. This is moving a takeoff point before a summing point. Means previously the takeoff point will be after the summing point. The representation will be like this. Here Hs is coming and the takeoff point is after the summing point, and we have to take the takeoff point before the summing point. We have to take the takeoff from here, and we will get the same output. Here Hs is being added. Means previously Hs and Rs both were added and going from this path, but if we take the takeoff point before the summing point, the Hs value is not coming. To provide the Hs value with Rs, we have to add the Hs value in this path Obviously now we have to add. Previously we subtracted. Now we have to add the value of hs, then we only get rs plus hs in this path. So I think you have understand all the 6 procedures by which we can simplify any block diagram, any huge block diagram representation, and this is the way to reduce any block diagram representation. So practice the basic ideas before I upload the next video on the example of block diagram block diagram reduction, and practice that will be a very important problem, and I'll give the link also in the description below. So if you like the video, don't forget to subscribe and also the bell icon. I'll come live later on, and if you have any questions in case of understanding any problem, then you can ask me. I'll try to solve that problem. Thank you.